So in today's video, we are going to revise the concepts of simultaneous linear equations. We are going to understand the different ways of solving simultaneous linear equations. And we know that linear equations are basically those equations which have a degree of 1. So linear equations are those equations with the degree as 1. So degree 1 basically means the power of the variables is equal to 1. The highest power of the variables is equal to 1. And the term simultaneous means we are talking about two or more equations which need to be satisfied at the same time, right? So you could also have more than two equations. So for example, I could have an equation like this, say 2x plus 12 is equal to 25. So this is a linear equation. It is linear because the highest power of x here is 1. So it is a linear equation. However, there is just one variable that I see. So this is a linear equation in one variable, right? And if I take the equation 2x plus 3y plus 5z is equal to 0, then this is also a linear equation. It is linear because the highest power of x, y and z is 1. So this is also a linear equation, but this is a linear equation in three variables where the variables are x, y and z. So you could have three variables. So x plus y plus z equal to 3. 2x plus 2y plus 3z is equal to 7, and x minus y plus z is equal to 1. You will notice that these are three equations in three variables, okay, and these are three equations in three different variables. The variables here being x, y and z, and you will notice that x equal to 1, y equal to 1 and z equal to 1 satisfies all the three equations at the same time. So let's quickly check. 1 plus 1, so 1 plus 1 plus 1 is indeed equal to 3. Then 2 times 1 plus 2 times 1 plus 3 times 1 is equal to 7, right? So 2 plus 2 plus 3 is indeed equal to 7. And 1 minus 1 plus 1 is also equal to 1. So you will notice that the value of the variables x equal to 1, y equal to 1, z equal to 1 do satisfy all the three equations at the same time, and this is why this is called the solution to the simultaneous equations. Solution to the simultaneous equations. So what it means is x equal to 1, y equal to 1 and z equal to 1 satisfies all the three equations at the same time. So the golden rule is the number of variables that you have should be equal to the number of equations that you have. If you need to solve a set of simultaneous equations for unique answer means if I want to get one single answer for x, y and z, then the number of variables should always be equal to the number of equations. So what it means is, if I am solving a two variable equation, then I should have two equations to solve for the value of x and y. if I have three variables, as was the case with the example shown over here. So if I have three variables, then I need to have three equations to find the solution. So let me take some more examples and explain what is meant by solution to the simultaneous equations. So let us now consider the equations x plus y is equal to 5 and 2x plus 3y is equal to 30. Now you will see that x equal to 2 and y equal to 3 satisfy the first equation. Satisfy the first equation basically means the first equation holds true when x is equal to 2 and y is equal to 3, because 2 plus 3 is indeed equal to 5. So x equal to 2, y equal to 3 satisfies the first equation. And let us now apply x equal to 2 and y equal to 3 in the second equation also. So 2 times 2 plus 3 times 3 is 4 plus 9, and 4 plus 9 is equal to 13. It means that x equal to 2 and y equal to 3 is also satisfying the second equation, right? So this value of x and y is satisfying both the equations. So this is the solution to the set of simultaneous equations. So now let me take another value of x and y. Let's try with a different value of x and y. Let's consider that x equals 5 and y equals 0. So let's consider x equals 5 and y equals 0. So 5 plus 0 is indeed 5. So x equal to 5, y equal to 0. This definitely satisfies the first equation. However, x equal to 5, that's 2 times 5, plus 3 times y, that's 3 times 0. So this is 10 plus 0, which is 10. And 10 is definitely not equal to 13. So x equal to 5, y equal to 0 does not satisfy the equation 2, right? Therefore, you will notice that there is a unique value, only one value of x and y, which will satisfy both the equations. And there are different ways of finding that particular value of x and y. So now we will try to list down the different values of x and y, different techniques that are useful in solving simultaneous equations. One method is definitely the graphical method. So graphical method involves graphing the two lines and finding the point of intersection. The second method is the method of elimination. So in the elimination method, we have already seen that we always tend to eliminate one of the two variables from the given set of equations. So our discussion is now going to be restricted to just two variables. So in elimination method, using the two equations, we tend to eliminate one variable and solve the other variable. And then using the known variable, we find the unknown one. The third method is the method of substitution. So this is the substitution method. Then there is a method which is the cross multiplication method. And there is another method which is equivalent to this cross multiplication method, and that is called Cramer's rule. Okay. So we will now discuss the graphical method, the elimination method, and the Cramer's rule in this particular segment. So let us now turn our attention to the graphical method. So what we do in the graphical method is we plot the graph of the two equations. So for example, say I'm supposed to solve for x plus 2y equal to 7, and say x minus y is equal to say minus 2. Okay. Assume that I'm solving for these two variables x and y, and these are the equations that are given to me. So what I will do is I will first plot the graphs for the line x plus 2y equal to 7. So how can I plot the graph? I will first create a table where I find some points that satisfy the given equation. Okay. So let's consider different values of x and y. The first equation is x plus 2y is equal to 7. So these are the values of x and y. Let's now start playing around with the values of x and y. So if x was equal to 1, if x was 1, then 1 plus 2y should be 7, which means 2y should be 7 minus 1. This means y is equal to 3, because 2y would be 6 and y would therefore be equal to 3. So x equal to 1 and y equal to 3 definitely satisfies the given simultaneous, definitely satisfies the first equation in two variables, right? So the first point is 1, 3. Then let's find one more point. Ideally, we should find 4 points, though mathematically speaking, 2 points are sufficient to draw a line. But still, just to be sure that we have made no mistakes, we end up plotting around 4 points. So let's try one more point. Now I will give you a small hint or a small technique to find the points. See, whatever is the coefficient of y, you should increase or decrease x by that coefficient. That means the coefficient of y is right now 2. So let us increase x by 2 in this table. So let's make it 3. And now let us find the value of y. So 3 plus 2y is equal to 7, which means 2y is equal to 7 minus 3, or 2y is equal to 4, which means y is equal to 2. So when x is equal to 3, y is equal to 2, and therefore the second point is 3, 2. Now again, let us increase the value of x by the coefficient of y. The coefficient of y is 2, so let us increase the value of x by 2. So now x becomes 5. So let's see what happens to y. 5 plus 2y is therefore equal to 7, which means 2y is equal to 7 minus 5, and therefore 2y is equal to 2, which means y is equal to 1. Now let us decrease 1 by 2, because 2 is the coefficient of y. I am going to change the value of x by 2. So instead of going to 7, instead of taking x as 7, what I am going to do is I am going to decrease x by 2. So x therefore becomes minus 1 in this case. So let us substitute x as minus 1 and let's figure out what values of y we get. So minus 1 plus 2y is equal to 7, which means 2y is equal to 7 plus 1. 2y is 8, which means y is 4. So when x is equal to minus 1, the value of y is 4. So the points are 5, 1 and negative 1, 4. So what these points mean is they are the points on the x and y axis. They are the points on the 2D plane which satisfy the given simultaneous, which satisfy the given equation in two variables. So what I'm going to do is I'm going to plot these points on the graph. So let's approximately plot the points over here. This is 1, this is the x-axis. So always mark your axis first after you plot your graph. So x is 1, y, x is 2, y, x is 3, x is 4, x is 5. Similarly, y is 1, y is 2, y is 3, y is 4 and y is 5. Let's take x equal to minus 1 also. Okay, 1, 3. So x equal to 1 and y equal to 3 is this point. X equal to 3 and y equal to 2 is this particular point. X equals 5 and y equals 1 is this point. And x equals minus 1 and y equals 4 is this point. So now what I will do is, I will just draw a line that joins all the 4 points. And this becomes the line that represents this equation. So all the points on this line will indeed satisfy x plus 2y equal to 7. You can just check. You will notice that your graph must be intersecting the x-axis at 7. So 7, 0 is also a valid point. Let's quickly check. X is 7. So 7 plus 2 times 0 is indeed equal to 7. So what this blue line is right now representing is set of all values of x and y, or set of all points that satisfy the equation x plus 2y equal to 7. Now similarly, we will have to plot points for x minus y equal to minus 2. So let's again draw a table, a nice table for x and y. And now we are going to focus on the second equation that we have. So the second equation we have is x minus y is equal to minus 2. So let's start off with those points. So we have x and we have y. The equation that I want is x minus y equals minus 2. Okay, if I take x as 0, so 0 minus y is equal to minus 2. 0 minus y is minus 2, which means minus y is minus 2, and minus minus sign will cancel. So the value of y will be 2, and therefore the point is 0, 2. Then I can also change the value of x now. So let's consider that my equation is x minus y equals minus 2. Let's take x as 1. Okay, so 1 minus y is equal to minus 2, which means minus y is, let's shift the 1 to the other side. So it becomes minus 2 minus 1, which means minus y is minus 3, or y is therefore equal to 3. So the point is 1, 3. Let us now take the next value of x. So instead of 1, let's consider the value of x as say minus 1. Let's take x as minus 1. So let's see what happens if x is minus 1. So minus 1 minus y is minus 2, which means minus y is minus 2 plus 1, which means minus y is minus 1. Minus minus sign cancels. So when x is minus 1, y is 1. Therefore the point is minus 1, 1. Similarly, let's take the value of x as 2. So if I take the value of x as 2, let's see what happens. So if I take x as minus 2, 2. So 2 minus y is minus 2, which means minus y is minus 2 minus 2, which means minus y is minus 4, and therefore the value of y is 4. So this point is 2, 4. Now let us plot all these points on the same graph. Okay. So x is, the point 0, 2, I know always lies on the y-axis. So 0, 2 is going to be here. Then I have 1, 3. 1, 3 is this point. Then I have minus 1, 1. That's going to lie somewhere here. And 2, 4. 2, 4 will lie somewhere over here. So these are the 4 points. And now what I'm going to do is I'm going to draw a graph, or I'm going to draw a line that passes through these 4 points. So the green line represents all the points that satisfy the equation x minus y equal to minus 2. I think we should write that down here. So green line is the set of all points that satisfy x minus y equal to minus 2. And the blue line that we have, blue line satisfies the set of all points that satisfy x plus 2y equal to 7. You will now notice that there is a single point or a unique point that lies on both lines. That is this point A, right? So the point A lies on the green line. It lies on the green line, as well as it also lies on the blue line, right? As well as on the blue line. Therefore, A satisfies x minus y equal to minus 2, as well as it satisfies x plus 2y is equal to 7, and therefore the point A is the solution to your set of simultaneous equations, because this value of x, so x is 1 over here and y is 3, I believe. So x equal to 1 and y equal to 3 satisfy both the equations. That is why that point lies on both lines, and therefore the solution to this simultaneous equations is 1, 3, which basically means x equals 1 and y equals 3. So when you are given two linear equations, you basically draw their graphs and you find their point of intersection. Wherever those lines intersect, that is basically the solution to your set of simultaneous equations. So let's take a couple of more problems related to this idea, and we should be able to find out some area of triangles also. So let's explore this work. Let me give you a couple of minutes to just take a look at this particular slide, and then I will take the next problem. Okay, let us continue. Let me take the next question. Okay, let's consider this given question. Solve the equations x plus 3y equal to 6 and 2x minus 3y equal to 12. Also find the area of the triangle formed by the lines and the y-axis. So I am going to go ahead and I am going to first plot this particular graph. Let's plot the coordinate axis. Okay, so I have drawn the axis, and now I wish to find, or I wish to draw the lines of this particular equation, right? So let's first take equation 1. So let us do all the working for equation 1. So equation 1 is x plus 3y is equal to 6. So let us plot the table quickly. We should generally plot 4 points. Yeah, so let's take x and y values. So first, every time you should always think of whether x equal to 0 and y equal to 0 will help me. So if I take x as 0, let's see what happens. So 0 plus 3y equals 6. So 0 plus 3y is 6, which means y has to be 2. So this is a good point, right? So therefore the first point is 0, 2. Now let me try to take y as 0 and let me see if that will work. So let's take x plus 3 times 0. I have taken y as 0. X plus 3 times 0 is equal to 6, which means x equals 6. So the other point is 6, 0. Let us now apply the trick that we just learned. Now I am going to increase x by the coefficient of y. So the coefficient of y is 3. So I am going to increase the value of x by 3. So 0 plus 3 is going to be 3. Similarly, let me also decrease the value of x by 3 from 0. So 0 minus 3 is minus 3. So let me quickly find the values of y when x is 3 and minus 3. So when x is 3, I have 3 plus 3y is equal to 6, which means 3y is equal to 3, which means y is equal to 1. Right, so this particular point is 3, 1, and now let me take x equal to minus 3. So minus 3 plus 3y is equal to 6, which means 3y is equal to 9, which means y equals 3. So the fourth point is minus 3, 3. So let us quickly plot these points now. 0, 2 lies on the y-axis. 6, 0 lies on the x-axis. So that's this point. 3, 1. So 3, 1 lies over here. Then minus 3, 3. So let's see where it lies. Minus 3, 3 is going to lie somewhere over here. So now I'm going to draw a line that joins these 4 points. Now because I'm drawing an approximate coordinate system, it is quite possible that it might not pass through all the 4 points in my case. But on your graph, because you are super accurate, you should be able to get the exact line. Okay, so the first job is done. We have plotted the points for x plus 3y equal to 6. Rather, we have got the line itself. Now we need to go ahead and plot the graph for the second line. Okay, so let us shift this particular set of points here. Okay, now the equation that I want to think about is 2x minus 3y is equal to 12. So let us quickly make some points. Again, I would like to think whether x equal to 0 and y equal to 0 will help me. Let's see if it helps me. So I have x and y, x equal to 0. So if x is 0, 2 times 0 minus 3y is equal to 12, which means minus 3y is 12, which means y is equal to minus 4. So the first point is 0, minus 4. Let us now take y equal to 0 and see if it helps. Sometimes you will not get a very nice answer for the variable. So in that case, you just drop that idea, right? So let's take y equal to 0 now. So 2x minus 3 into 0 is 12, which means 2x is equal to 12 or x is equal to 6. So if y is 0, x is 6. So the point is 6, 0. Let us now take a different set of points. So again, let's apply the same technique. What is the coefficient of y here? The coefficient of y is 3. So let's reduce or increase x by 3. So it becomes 3. So let's see what happens. 2 times 3 minus 3y is equal to 12. So 6 minus 3y is equal to 12. Minus 3y is equal to 6, which means y is equal to minus 2. So the value of y is minus 2. The point is 3, minus 2. Similarly, let us now decrease the value of x by 3. So let's take x equal to minus 3 and let's see what happens. So instead of x equal to 3, I will now substitute minus 3. So 2 into minus 3 minus 3y is equal to 12. So minus 6 minus 3y is equal to 12. So minus 3y is 18, which means y is equal to minus 6. So the point is minus 3, minus 6. Now again, let's go ahead and plot these points. 0, 4 is, 0, minus 4. Okay, so we didn't plot the negative y-axis. Let's plot it. So this is 0, minus 4. Then 6, 0 is right over here. Then I have 3, minus 2. So 3, minus 2 is going to lie over here. And minus 3, minus 6, minus 3, minus 6. Let us plot the point. So minus 3, minus 6 would lie somewhere over here. And now I will draw a line that basically joins all these points. Again, because of the inaccuracies in my axis, it's quite possible that the line may not pass through all the points. But now I think we have found a solution to this. These two lines are intersecting at the point P of 6, 0, and therefore I can say P of 6, 0 is the intersection of the 2 points, of the 2 lines, of the 2 lines. And therefore, the solution to the simultaneous equations is x equal to 6 and y equals 0 is the solution. Right? And now they have asked me also find, so let's see if this is really true by the way. X plus 3y is equal to 6. Let's substitute 6 and 0. So 6 plus 3 into 0 is indeed 6. So it satisfies the first equation. And 2x minus 3y is equal to 12. So 2 times 6 minus 3 times 0 is equal to 12. So 12 equals 12 and it satisfies the second equation. So x equal to 6 and y equal to 0 is a valid solution. Now they have told me, or they are asked me, also find the area of the triangle formed by the lines and the y-axis. So let us quickly darken our lines. One line was like this. The other line is right over here. And then you have the y-axis. Y-axis is this line. The triangle that is getting formed, if you carefully notice, is this triangle. Right? This is the triangle that they are talking about. So we need to find the area of this particular triangle. So what is the formula for area of a triangle? Area of a triangle is given by half into base into height. So if you consider the given triangle, this is one vertex. So let's mark all the vertices. This is the vertex, say Q. And what are the coordinates of this vertex? The coordinates of this vertex are, let me erase this. So the coordinate of the vertex Q is 0, 2. And this is the third vertex of the triangle. So let this be R. So the coordinate of this vertex is R of 0, minus 4. So if I want to find the area of this blue triangle, I can consider QR as my base. So how much is the length of QR? You will notice that Q is 2 levels above the origin and R is 4 levels below the origin. Therefore, the complete base is 6 units, right? So the area will be half into base is 6 units. And the height, because we know that the x and y axes are perpendicular to each other, the height can be considered as OP. And the measurement of OP also happens to be 6. So half into 6 into 6 is going to be 18 square units. Therefore, the area of this triangle is 18 square units. Again, the base is 6. So QR is 6 units. And OP is the height, which is also 6 units. And therefore, the area is half into 6 into 6, which is 18 square units. So let me pause around for a couple of minutes, take a look at this solution, and then we will continue. Okay, let us now take the next question. Okay, let's consider this question. Draw the graphs of 2x plus y equal to 6 and 2x minus y plus 2 is equal to 0. Find the solution and also the area of the triangle formed by the lines and the x-axis. So now let's take these two equations and let's plot our graphs. So what I'm going to do is I'm going to plot the graphs of both the equations. They will be straight lines. I'm going to find the point of intersection and then I'm going to find the area formed by the lines and the x-axis. So let me go ahead and plot my coordinates. Okay, so I have my axis ready and now let's plot x and y. So again, let's think of whether x equal to 0 will work. So if x is equal to 0, 2 into 0 would be a 0. So y would be equal to 6. So 0, 6, I think that's a good point to have, 0, 6. Now let's change x by the coordinate, the coefficient of y that you see. The coefficient of y is 1. So let's take x as 1. So let's find the value of y now. So 2 times 1 plus y is equal to 6. So y will therefore be equal to 4. So when x is 1, y is 4. So the coordinate is 1, 4. Let us now check if y equal to 0 works. So if y is equal to 0, let's see what happens. We get 2x plus y is 0 is equal to 6, which means x is equal to 3. So y equal to 0 and x equal to 3 works well for me. So this is 3, 0. And now let's change x by one more. So let's take x equal to 4. So let's see what happens to y. So 2 times 4 plus y is equal to 6. 8 plus y is equal to 6, which means y is minus 2. So the point is 4, minus 2. So I think now it's going to be an easy task to just plot the points on the graph. Let us do it quickly. So the first point that I have is 0, 6. Let's plot that point. So 0, 6 is going to be somewhere here, yeah, on the positive y-axis. Then I have 1, 4. So 1, 4 is somewhere here. Then I have 3, 0. 3, 0 is somewhere here. And 4, minus 2 is somewhere over here. So these 4 points will therefore form a straight line. And the red line therefore represents the graph for 2x plus y equal to 6. So it's always a healthy practice to write the equation on that line. So 2x plus y is equal to 6. This is the equation of the first line. Let us now take the second equation and plot its points. So let me just erase these points. Okay, so let us take the equation is now 2x minus y is equal to minus 2. So I'm just shifting the 2 to the other side, so it became minus 2. Again, let me check if x equal to 0 will work. So if x is equal to 0, this becomes 2 into 0 minus y is equal to minus 2. So minus y is minus 2, which means y equals 2. So the point is 0, 2. Then let's take y equal to 0, right? So if y is equal to 0, let's see what happens. So I have 2x minus 0 is equal to minus 2, which means 2x equals minus 2, which means x equals minus 1. So if y is equal to 0, x is minus 1. So the point is minus 1, 0. Now the coefficient of y is 1. So I am going to change the value of x also by 1. So instead of 1, let me change the value of x by 1. So let it become 1. So 2 times 1 minus y is minus 2, which means 2 minus y is minus 2, or minus y is minus 4, which means y is 4. So when x is equal to 1, y has to be 4, and therefore the point is 1, 4. And now let's go for the fourth point. Let us increase x by another 1. So let's take x equal to 2. So let's see what happens. 2 times 2 minus y is equal to minus 2. 4 minus y is minus 2, which means y is equal to 6. So the point is 2, 6. So let us now plot the points. 0, 2 is somewhere over here. Then minus 1, 0 is somewhere over here. Then 1, 4 is going to be here. And 2, 6 is going to be somewhere over here. So now what I will do is I will plot a line which passes through these 4 points, and this particular line represents the equation 2x minus y plus 2 equal to 0. So now we have found the solution. The solution to these simultaneous equations is where the lines intersect. They are intersecting at x equal to 1 and y equal to 4. So therefore the solution is x equals 1 and y equals 4 is the solution to the set of simultaneous equations. And now they are asking me find the area formed by the lines and the x-axis. So let us quickly draw the triangle between the lines and the x-axis. Let's quickly draw it. So this is one line, yeah, and this is the x-axis, and this is the other line, yeah. So now I am supposed to find the area of this particular triangle. So now let me think of how to find the area of this triangle. Again, I am interested in finding the base. So the base is the distance between, suppose I label the points as A, B and C. The base of this triangle is going to be AC. So A is 1 unit to the left of origin and C is 3 units to the right of origin. So base is 4 actually. 1 plus 3 is 4. And the height of this triangle is nothing but it's the perpendicular distance between the point and the x-axis. So basically this is going to be 4 units. It is the y coordinate of that point. So this height is going to be 4 units, right? So the height is 4 units, and therefore the area of the triangle ABC will be given by half into base into height. That is going to be 8 square units. This is the area of this given triangle. So this is how we solve the simultaneous equations using graphs. We plot the two lines, and there are a few techniques that I showed you where you check if x equal to 0 works, y equal to 0 works, and you change x by the coefficient of y, and then you will get some good points. So you plot both the lines and you find the point of intersection. That basically gives you the solution to the set of simultaneous equations. And if you wish to find the area of the triangles, you find the base and height graphically, and you find the area of the triangle using half into base into height. So this is how you can go about the graphical method for solving simultaneous equations. I will again pause for a couple of minutes and then I will give you a few problems to solve. Okay, so now let me give you a few equations for your homework. Okay, so the following questions will be your homework. I am going to keep this on for another minute so that you can take a picture of this for your reference, and you can solve these questions as your homework. Okay, that's it for today then. Thank you. Bye bye.